Hey kids, Mr. Murray here, back on Mr. Murray's Math Land. Today we're talking about parallel and perpendicular lines, and specifically writing the equation of lines that are parallel or perpendicular to a given line. So, quick review of the words parallel and perpendicular. I think you know what they mean, but parallel, two lines that do not intersect. You'll learn a little bit more about them in geometry. But the main thing with parallel lines is since they don't intersect, that means that they have the same slope. That's what's important for our purposes today. And perpendicular lines, oh man, you do a lot with these in geometry, but perpendicular lines are two lines that intersect or meet at right angles, so at 90-degree angles. And even just from my little crude diagram here, you can see that one of the two lines has a positive slope and the other has a negative slope. So they definitely don't have the same slope. One is positive, one is negative, so that's what we call opposite. And there's actually a little bit more to it. They have opposite reciprocal slopes. We've talked about reciprocals of fractions before. So we'll get into this with the examples we see, but that's the major idea here, that when you see parallel or perpendicular right now in terms of what we're doing, you got to think that's really just trying to give me a clue about the slope of my line. So in number one, we're trying to write the equation of a line in slope-intercept form, so that's y equals mx plus b, that passes through this point and is parallel to this line, 6x plus 8y equals 13. So parallel means these two lines are going to have the same slope. I'm trying to write the equation of a line that has the same slope as this line right here. Okay, so what's the slope of this line, 6x plus 8y equals 13? Well, it's not in slope-intercept form, so one way to find its slope would be put it in slope-intercept form. So let's solve this for y, this equation. Let's put it in y equals mx plus b form. So I'm going to subtract 6x, subtract 6x. Hopefully you've done this enough from things we've done earlier in the chapter that this comes pretty naturally to you at this point. So I subtract 6x. I have 8y equals negative 6x plus 13. I'm going to divide by 8 to isolate that y. And now I'll have y is equal to negative 6 divided by positive 8 is negative 3/4 x plus 13/8. Now this line has a slope of negative 3/4. And that means my line, I'm trying to write a different line altogether. That means my line must have the same slope as that. So all of this was just a big way to try to tell me, hey, write the equation of a line that has a slope of negative 3/4. And your line, the line we're trying to write, passes through this point, negative 12.5. So mine is going to have the same slope, but it's going to have a different y-intercept than this line they gave me. Right? It's a different line altogether. It just has the same slope. So again, this was all about, using this was just all about getting to that slope. And now this is just like any other problem I've done here. Write the equation of a line that has a slope of negative 3/4 and passes through negative 12.5. And even to do this, I have two options. I could use point-slope form if you feel comfortable, and then change it to slope-intercept form. Or I could do the classic start with y equals mx plus b and plug in what you know, meaning I know the slope is negative 3/4 x. I just need to solve for b, and I will do that by plugging negative 12.5 into this. 5 goes in for y equals negative 3/4 times negative 12 goes in for x, and I'm going to solve. Negative 3/4 times negative 12 is positive, and 3/4 of 12 is 9, positive 9. And again, you can do that by doing 3 times 12 is 36, and 36 divided by 4 is 9. Or remember, you can do 4 goes into 12 3 times and then do negative 3 times negative 3 is positive 9. However you like to do it. But either way, we get positive 9 there. And now to solve for b, just going to subtract 9 from each side. So b is equal to negative 4. So now I've got my b to go with my slope. So my line is y equals negative 3/4 x minus 4. That is the final answer. And notice, if you were to graph these two lines, this one and the one they gave, they would have two different y-intercepts. They'd be starting from two different points, but since they'd have the same slope, they would be parallel to each other. Okay, so now let's just try one more example here. This time a perpendicular example. Write the equation of a line in slope-intercept form that passes through 8, negative 11, and is perpendicular to this line. Okay, so again, perpendicular is just a way to try to tell you about its slope. That means my line, the line I'm trying to write, has the opposite reciprocal slope of this line, 9x minus 6y equals 21. So again, let's put it in slope-intercept form just so I can see its slope. So I know what I'm dealing with here. So I'm going to subtract 9x from each side. I'll be left with negative 6y equals negative 9x plus 21. Divide both sides by negative 6, divide by negative 6, divide by negative 6. Y is equal to negative 9 divided by negative 6 is positive 3/2 x. And, to be honest, I don't even really care about its y-intercept. But just for practice, positive divided by negative is negative, and 21/6 reduces to 7/2 when you divide each by 3. But all I really wanted was, what is the slope of this line? That's what it was all about. And if the slope of this line is 3/2, that means mine has to be the opposite reciprocal of that. So the opposite reciprocal of positive 3/2 is negative, so it always has the opposite sign. That's what opposite means. And reciprocal means, you flip the fraction. So instead of positive 3/2, negative 2/3. So that's my slope for my line. And my line passes through the point 8, negative 11. And so now let's write the equation of the line that goes through there. So we could do this again with y equals mx plus b and plug in, or I could start with point-slope form. So I think I'll do point-slope form just for fun here on this, since we did it the other way in number 1. So I'm going to start with point-slope form, which is y minus the y-coordinate of my point. So y minus negative 11 is y plus 11 equals the slope, negative 2/3, times x minus the x-coordinate of 8. That's point-slope form. And now to put it into slope-intercept form, I'm going to distribute that negative 2/3 and subtract 11 from each side. Don't try to do too much at once, though. Let's get rid of those parentheses. Negative 2/3 times x is negative 2/3 x. Negative 2/3 times negative 8. Negative times negative is positive, and 8 times 2/3. Now, it's not going to go in evenly. 8 times 2 is 16 over 3. So 16/3 does not reduce, so I'm just going to leave it that way. Got to be comfortable dealing with fractions here at this level. And now I'm going to subtract 11 from each side. Subtract 11, subtract 11. Now when I subtract 11 from here, I've got to do 16/3 minus 11. I'm going to make a common denominator here. This is really 11 over 1, so let's put it over 3. So make a common denominator with this 16/3, so that's really 16/3 minus 11 over 1. I need to multiply the bottom by 3, so that becomes 3, and multiply the top by 3. 11 times 3 is 33, right? Because 33/3 is really just 11. I just wrote it with a common denominator. And so now my final answer is y equals negative 2/3 x, and 16/3 minus 33/3 is negative how many thirds? The denominator doesn't change when you add and subtract. Just 16 minus 33. Subtract your numerators. 16 minus 33 is negative 17/3, which does not reduce. So we're going to leave it that way. Okay, so got a little bogged down there with the fractions and the common denominator, but the real focal point of this was using the slope being the opposite reciprocal. Slope of 3/2 on this line means my slope was -2/3, and then trying to get it into slope-intercept form after that, however you like to do it. So okay, kids, 2 examples there. Hopefully that helps. If any questions, as always, just ask. Have a good day.